Hi, in this video, I'm going to show you how to solve differential equations by variable separation. To start with, differential equations connect functions and their derivatives. And in order to pass your A-level exam, the only technique you have to know is variable separation. So the idea is simple. First of all, you will have to collect all x on one side and everything with y on the other side. For example, let's have a look at this one. Let's say dy over dx equals to 2y. So as you can probably see, dy is on the left side and then y is on the right side. They're on different sides of the equation, so that's not really good. So the first thing I'm going to do is to multiply both sides by dx. And then I will get dy equals to 2y dx. Right. So our goal is to combine y with dy on the left side, and then everything with x should be on the other side. So I'm going to divide both sides of the equation by y. So I'll get dy over y equals to 2 dx. So we have y and dy on the left side, and then we technically don't have x, but we get dx on the other side. So now the variables are separated. So we have all y's on the left, and then x is on the right. So that means we can integrate both sides of the equation. Now the integral of 1 over y is going to be natural log y equals to 2 x. Then don't forget to add c, the constant of integration. And then usually you will have to express y in terms of x. So how do we get off a natural log? We can raise both sides to, we can raise e to the power of every side. So we'll get y equals to e to the power of 2x plus c. So technically we've solved the differential equation, but we can write our solution a little bit nicer. So if we use laws of indices, we could just write it as e to the power of 2x times e to the power of c. Now, e to the power of c is just a number, right? It's not a variable. So we can just call it as a different letter. Let's call it a, for example. And our solution will be y equals to a times e to the power of 2x. Now, let's have a look at the more difficult example. I've taken it from a Cambridge past paper. So here's our equation. I'm just going to write it separately. So my first step is going to be to multiply both sides by dx, and I will get x dy equals to 2 minus x squared y dx. Now, we'll have to separate the variables. So everything with y and dy should be on one side, and everything with x and dx should be on the other side. So I'm going to divide both sides by y. I'll get x dy over y equals to 2 minus x squared dx. Now, I want to move this x from left side to the right side, so I'll divide both sides by x. And I will get dy over y equals to 2 minus x squared over x dx. Now, y and dy are on the left side, and then x and dx are on the right side. So that means our variables are separated. And we can start integrating. So the integral on the left is going to be, again, natural log y. And in order to integrate the right side, I will just have to split the fraction into 2 over x minus x squared divided by x is going to be just x. Got dx. And on the left, we got dy over y. Okay, so now our integral of 1 over y is going to be natural log y equals to natural log x minus integral of x is going to be x squared over 2. Okay, and then don't forget to add c, constant of integration. Okay, now our goal is going to find c. Okay, and in order to do so, we'll have to use the point on a curve. Here we know that the point 1, 1 should satisfy the equation of our curve. So let's substitute x equals to 1 and then y equals to 1 into our equation. So we'll get log 1 equals to 2 log 1 minus a half plus c. Now the natural log of 1 is 0, so we'll get 0 equals to 0 minus a half plus c, and that gives us c equals to 1 over 2. Okay, now put it back into the equation, and we'll get log y equals to 2 log x minus x squared over 2 plus a half. And then same as in the first example, we'll have to get rid of natural log next to y. So it means y equals to e to the power of the right side, which is e to the power of 2 log x minus x squared over 2 plus a half. And then again, technically we're done, but we can write our answer a little bit nicer. Again, using laws of indices. So I'm going to split it into e to the power of 2 log x times e to the power of 1 over 2 minus x squared over 2. Okay, why did I do this? Because in the next step, I can write 2 times log x as log x squared. Okay, now what's going to be e to the power of natural log of x squared? Well, e to the power of natural log, that will just cancel each other. So I'll get y equals x squared times e to the power of 1 minus x squared over 2. That's our solution of the differential equation. And the next example is going to be a little bit harder. It's a 9-mark question. I'm sure all students who got this question in the actual exam actually appreciated this. Okay, because in that question you'll have many topics combined together. That's obviously differential equations, you'll have partial fractions, and of course you'll have a little bit of integration going on. Okay, so first of all, let's write down the equation separately. Dy over dx. Okay, same as before, I'm going to multiply both sides by dx. And for the next step, I'll have to separate the variables. That means have y and dy on one side, and then x and dx on the other side. So in order to do so, I will divide both sides by y, to move y from the right side to the left. And I'll also divide it by the two brackets with x. So I will get dy over y equals to dx over the two brackets. Okay, so now I have y and dy on the left, and then everything with x and dx on the right side. So that means the variables are separated, and we are ready to integrate. Again, on the left, we'll have natural log y, and the right side is a little bit tricky, yeah, because we have to integrate a fraction. And before we do so, we'll have to separate this fraction into partial fractions. So, okay, it's going to be 1 over x plus 1, and then 3x plus 1. In the denominator, we have two linear factors. So that means this fraction can be split into a over x plus 1 plus b over 3x plus 1. Okay, so now I will combine these two again back into a single fraction. So a times 3x plus 1 plus b times x plus 1. Okay, now I'm going to look only at the numerators of the two fractions. Basically, I'm trying to find the number a and b such as 1 would be equal to a times 3x plus 1 plus b times x plus 1. Now, a times 3x plus 1 plus b times x plus 1 should always be equal to 1, no matter what x is. So that means I can substitute any x I find convenient. And that will be x equals to minus 1. Why? Because x equals to minus 1 will turn x plus 1 into 0. And I will only have 1 equals a times 3 times minus 1 plus 1. That will be minus 2. And that gives me a equals to minus a half. Now, what number will turn 3x plus 1 into 0? That is minus a third. Okay, and I will get 1 equals, next to a is 0, and next to b is minus a third plus 1, that will be 2/3. That means b equals to 3 over 2. Okay, now we're done with partial fractions, and we can move on to our integration. Let me copy the question. So I got the integral 1 over y dy equals to, I'm going to replace the fraction with partial fractions. So it's the integral of minus 1 over 2 x plus 1 plus, now b is 3 over 2, 3 over 2, and at the bottom we've got 3x plus 1. dx and dx, of course. Okay, and now we can integrate. The integral of 1 over y is going to be natural log y equals to minus a half. Now we got the integral of 1 over x plus 1, which is natural log x plus 1, plus 3 over 2, natural log of 3x plus 1. And then it's very important to not to forget divide it by 3, yeah, the number next to x. 3. And of course, plus c. Okay, now our goal is to find c at the moment, right? So it's given that y equals to 1 when x is 1. So that means I can substitute the point 1, 1 into this equation. Okay, substitute 1, 1. Okay, let's do that. So log 1 equals to minus a half log 2 plus 1 over 2 log 4 plus c. Okay, natural log 1 is 0 equals to minus a half log 2 plus a half, and instead of 4, I'm going to write 2 to the power of 2 plus c. Why? Because I want to combine the two logs together, and writing 4 as 2 squared gives me a chance to move 2 in front of the log. So I get 0 equals to minus a half log 2 plus natural log 2 plus c. And I get 0 equals to a half log 2 plus c. So that means c equals to minus 1 over 2 natural log 2. Okay, put this c back into this equation. So we get log y equals minus a half log x plus 1 plus 1 over 2 log 3x plus 1 plus c, which is minus a half log 2. Okay, now let's have a look at our original question. What are we supposed to find? Find the exact value of y when x equals to 3. Okay, let's substitute x equals to 3 and see what we get. We got minus a half log 4 plus a half log 10 minus 1 over 2 natural log 2. Okay, now it looks like we can factor out 1 over 2, and we get log 10 minus log 4 minus log 2. Now, if we use laws of logs, we will get log 10 over, now 4 and 2 will go to the bottom of the fraction. And we got log y equals to 1 over 2. Natural log, that's simplified, so it's going to be 5 over 4. Okay, almost there. Let's move 1 over 2 as the power of 5 over 4. So log y equals to log 5/4 to the power of a half, and the power of a half is the square root. Okay, so that means y equals to the square root of 5/4. And as the final answer, I will give the square root of 5 over square root of 4 is, of course, 2. Okay, so here we go. That's the final answer. Now, I hope this video was helpful. And if you'd like me to make more videos on some specific topics, let me know. And also, please let me know in the comments if you have any questions about this video. Thanks a lot for watching. Bye.